Um, this is just a little summary of transistors. What's so special about transistors? What they've allowed people to do. Transistors are often called the most important invention of the 20th century. Um, and I think it's worth it to talk a little bit about why they have had this incredible impact. Um, it certainly is the basis for all modern electronics and computing. Um, no electronic devices that you use now would be possible without transistors. Um, and so the history of transistors really starts with vacuum tubes. In 1904, the first vacuum tube was created. And what it did was allowed a current through one pair of electrodes to be controlled by a current through another pair of electrodes. And this was useful in two ways. So it's used for, first, you could use it as an amplifier, where the controlling current could be a small current, and it could be used to control a bigger current. And so the immediate use was in radio transmission and telephones. And then the second use of it was it could be used as switches. So currents happening at one part of, say, a calculation could then be used to manipulate currents at a different part. And you can probably sort of vaguely imagine how that would be useful if you're trying to put together a complicated system of calculations like you do in a computer. So switches are the part that's needed for computers. Um, in the 1940s, people started working on something that would do what a vacuum tube does, but do it with solid state electronics that has to do with quantum effects. So people started working toward a solid state. And I'll put that in quotes because solid state means sort of a specific thing. Version of the vacuum tube. And this solid state version used semiconductors. And semiconductors are materials that don't don't conduct electricity, But so normally they don't conduct electricity, but they do if they're doped, it's called, by another specific material. So on these very small semiconductor packages, you can be very precise about where electricity can travel and where it can't. And you can also get some strange quantum effects that allowed transistors to be invented. So this was the transistor. It basically was an attempt and a successful solid state version of the things that a vacuum tube could do. The first one that people got working was in 1948, and you've already seen the video on that about Bell Labs. And the leader of the group that did it was William Shockley. That's a famous name. Shockley is a good name for an electrical engineer. And so let's talk about the benefits of this solid state version, the transistor, versus the vacuum tube that came before. So these are the benefits over vacuum tubes. First, these could be made in a much smaller package. And it wasn't obvious at first how much smaller it could be, but now single silicon chips have over 2 trillion transistors on them, whereas vacuum tubes have to sort of be macroscopic size, like even the smallest ones that have ever been made. You can see them as you hold them in your hand. Second, transistors require much less power consumption. And along with that, they produce much less heat. And so all of these things that I've mentioned here so far are leading towards the ability to put a ton of transistors in the same spot for more complicated calculations compared to the number of vacuum tubes that you could have in a spot. Third, they last longer. The components of vacuum tubes wear out, and so these vacuum tubes had to regularly be replaced. I mean, imagine if you had to go into your computer regularly and replace transistors on the chip. It would be impossible. Fourth, transistors are more physically robust. These vacuum tubes had glass components in them and filaments that could be broken by jostling. And eventually, it wasn't this way at first, but eventually transistors became very cheap and fast to manufacture. Transistors, just like vacuum tubes, can be used as amplifiers. In this class, that's not going to be what's important to us. So they can be used as amplifiers. And, I don't know if you've thought about it this way before, like what's the relationship between an amplifier in your audio equipment and an electronic amplifier? In either case, all you're doing is you're trying to use a smaller signal to generate a higher magnitude signal. That's what you're doing to your music, and that's also what an electronic amplifier does. But for us, in this class, we're just going to use transistors as switches. Well, when you get to your big project, if you want to try to take advantage of some of the amplification ability of transistors, we can do that, but everybody's going to use transistors as switches. So there are two main types of transistors. And really, for our purposes in this class, neither is better than the other one. The first one is called a MOSFET. This stands for metal oxide semiconductor field effect transistor. And the second type is called BJT transistor, or bipolar junction transistor. MOSFETs overall in production are by far the most important one, the most used. 99.9% of all transistors manufactured in the world are MOSFETs. And that's because their switching ability is faster. So you can operate them on faster, like in a computer, a faster clock cycle. And they use less power, and they produce less heat. So those are all good things, and they're cheaper to manufacture. So really, there are no real advantages for bipolar junction transistors. But bipolar junction transistors were the first ones developed. And so in this class, the way that we are going to use it is this. So I'm going to show, the symbol that I'm going to use is for, this is all terminology you don't have to remember, but this is for an NPN enhancement type MOSFET. And we're going to use it something like this. So we are going to program microcontrollers where our program sends voltages to pins in the microcontroller. When we've sent a high voltage to one of these pins, we'll put it through a resistor. So that's just a small resistor. And this is the symbol for an NPN MOSFET. Okay, so this is an NPN MOSFET. This symbol here is the ground, so there's always going to be some ground potential. And say that we want to use, so when we program, we do some calculations, and when those calculations increase the voltage on one of our microcontroller pins, and put it at like a positive value, say that we want to turn on a motor. Okay, well, the pins on our microcontroller can't produce anywhere near the amount of current that we're going to need to run a motor. So let's say that we'll call this a motor, but it also could be a light. It could be, there are all sorts of electronic devices that this could be. And let's say that we need 24 volts and quite a bit of current to power this motor. Well, the way this works is we're not using current from the pin to run this motor. Instead, we're using current from the pin. Well, in fact, we're using voltage from the pin, but we don't have to worry about anything like that yet. To open or to close a switch that allows current to run from the 24-volt battery through the motor. And so it's not that the pin is providing the power to the motor, but the pin is giving the signal that allows the motor to start running. And so in this class, the benefit of transistors to us is that we'll be able to use these very small voltages and small currents to control when very big currents are running. That's only one of the many things transistors can do, but that's how it's going to be useful to us. If that didn't make a lot of sense to you, that's fine. We're going to go through the electronics we need. We're going to talk in more detail about this. But for now, just remember that the way we're going to use transistors in this class is we're going to use transistors so that we can take a small voltage or a small current and use that to control when a big current powers a device.